I am taking 3 classes this semester. Probability theory is the one I think I've talked about the most, and the other being convex geometry, or the class is really called problems in uniqueness, but I call it convex geometry. And the third one, which I've rarely spoken about, I don't even know if I've really mentioned it all that much, is analytic number theory. The reason I don't talk about it very much is because we don't get a whole lot of assignments in the class, so we just kind of show up, take notes, and that's it. There's no real tests in that class. And we're graded based on homework assignments. And yesterday, we were given our very first homework assignment. And I printed, well, okay, not the very first. I don't know why I said that. The third homework assignment is given here. So this is 3 pages, but as you can see here on the first page, it says that we get choices. So do any 3 or more problems. Number 4 is counted as 2, and number 5 is counted as 3. So if number 5 is counted as 3, then in theory, you just do number 5, and then you're done. I'm not sure if you do like parts of number 5, and then that counts as like maybe 1 or 2 problems, and then the rest, you know, you make up from there. I don't know. I should probably ask him that question. Although, to be fair, I'll probably just follow the instructions and try and get it answered that way. Anyway, so I thought I would just make a video about analytic number theory because I don't talk about the class much. So we'll look at these problems. Here's the first one. Let chi mod q be non-principal. X is bigger than or equal to 1. Show that for any alpha positive, you have that the sum is equal to the L function alpha chi plus big O of x to the negative alpha, where the big O constant depends on q only, and the L function is defined as follows. Also show that for non-principal chi mod q, x bigger than or equal to 2, you have this equation here. So I looked through this homework assignment before recording. I think number 1's not too bad. His homework assignments are usually very much, like if you understand the notes, or if you look at the notes for inspiration, then the homework problems aren't too bad. Other classes that I have, the homework, or excuse me, the notes don't really help too much with the homework. But for this guy, that doesn't seem to be the case. As long as you have the notes in front of you, you can piece together an argument that makes a lot of sense. Okay, so suppose chi mod q is a real character. Let an be defined as follows. Show that an non-negative for all n integers, and prove that an bigger than or equal to 1 is a complete square. That one might not be too bad either. I have to look over my notes. It's been a while since I've read through it. The problem with this is that my probability theory exam, the second one, is in like 2 weeks, and I haven't really studied for it because I was stupid and did not study over the break. I studied a little bit, but I studied like in the beginning, and then I got caught up doing other things, so I didn't really study. Which means now I have to juggle this assignment with studying for that probability test. You can see up here that the assignment is due April the 18th, so I have a couple days to do it. For non-principal real character chi mod q, let an be a function defined in problem 2. Let tx be defined as follows. Show that tx is equal to 1/2 L function 1 chi x to the 1/2 plus big O of 1. And that tx is bigger than 1/2 log x. And then he has a remark. Okay, problem 4. I believe problem 4 he said would count it as 2 problems. Suppose q is an odd prime, gl is defined as follows, a gender symbol, and we want to prove that g1 is equal to sq, or yeah, g1, where sq is equal to this guy. Prove that g1 squared is equal to -1 raised to the q minus 1 over 2q, and this equation. I'm not really a big fan of number theory. I'll put it this way, there are topics in number theory that I like the Riemann zeta function, but as a whole, I'm not a big fan of number theory. Okay, number 5. So number 5 is the one where if you solve number 5, you don't have to do any other problems. and it's about the prime number theorem. So PNT stands for prime number theorem. I'm not sure what AP stands for here. Suppose Q is bigger than or equal to 3. The GCD of L and Q is 1, so they're coprime. And X is greater than or equal to 2. Prove A through E. You can use the results from other problems in this homework. For any arithmetic function Fn, we have this equation. So we have to prove that. If chi is not equal to chi 0, then this sum is equal to this thing. Suppose chi is not equal to chi 0, and gx is this, and L1 chi is that. Show that we have this relation, or two relations that is. Man, this doesn't look easy, does it? There's a lot of symbols here. If you don't know what the symbols mean, you're kind of stuck. But if you know knowing the definitions is half the battle in a lot of these graduate courses. As long as you understand what the symbols are, the work is half done. You just have to use some tricks you pick up along the way in class. And he gives us a hint, which is kind of nice. Part E. Let NQ be the number of complex characters chi mod Q such that L1 chi is equal to 0. Prove that this sum of log P over P is equal to 1 minus NQ over phi Q log X plus big O of 1. Which yields this thing. Number 5, using the result of number 6, using the result of 5, show that there is a constant ALQ such that this sum of 1 over P, where P is congruent to L mod Q. Is that an L or a 1? I can't read it. I think it's an L. Anyway, so the sum is equal to 1 over phi Q log X plus ALQ plus big O of log inverse of X. Oh, number theory. Suppose chi is non-principal character modulo Q. Prove the following. I can already tell you that I'm going to have to search the internet for some of these solutions. My number theory is not that great. Suppose Q is bigger than or equal to 2. Prove the following. Chi of negative 1 is 1, then L0 chi is 0. If chi negative 1 is negative 1, then L0 chi is equal to this expression. So it looks to me, just by looking at these problems, that I need to review my characters. They're not the characteristic functions here. They mean other things, but there's a lot of algebra in here, and I did not take algebraic number theory. I just went straight to analytic number theory. And I kind of wanted to take algebraic number theory last semester, but there's no way I would have been able to take it, probability theory 1, and then the potential theory that I took, as well as complex variables 2, because I took complex variables 2 last semester. That had been 4 classes. There's no way I would have been able to do that, plus teaching on top of that. But so far, from the other people that are in this class that did take algebraic number theory, they said that this is very different from last semester. So, but it would have been nice to have like a complete rounded, course selection. I don't know what I'm trying to say. It's too early in the morning for me, and I need to get ready for work. So this morning I'm actually going in to take my convex geometry class. And I actually got a book in convex geometry, which is over here. A Course in Convexity by Alexander Barvanok. It's an AMS book. So whenever you see books that have this cover, it's usually from the American Mathematical Society. These AMS books are really good so far. I went to the library at my university, and my library is pretty huge, but I did not expect them to have as many textbooks on mathematics as they did, because I went to their section to look for a very specific math book, which I'm going to make a video over here shortly. But when I was there, I found it, but I also just looked at all of the books that they had, and I was a bit surprised. And I wanted to check out a bunch of them, but there's no way I would have been able to read all of the books I wanted to read. But I found this book, and I thought that it was too good to pass up, so I decided to borrow it and at least read through it. I'm still working on chapter 1. I just borrowed it yesterday. But I think it might help me in my research because my geometry background is a bit limited. Hold my camera steady so you can read the table of contents. Because I looked up the table of contents just to flip through it, and then I read just a tiny bit, like I opened up somewhere random in here and just looked at the way it was formatted. And I was like, okay, maybe I should consider checking this book out and reading it. So hopefully it'll be worthwhile. Anyway, so that's what's on my to-do list. This guy, study for probability theory, and then casually read my convex geometry book. Anyway, thank you for watching.